Okay, here we have another question, so let's get through this. Suppose someone has 3 outstanding loans. The first one is cleared by a repayment of £300 in 2 years, the second loan is a repayment of £150 in 4 years, and the third loan is a repayment of £500 in 5 years. Alright, so let's draw that on a timeline. So let's say here we are, t is the timeline, and here we are at time 0. So after 2 years, this could be 1 year, after 2 years you've got to pay an amount of £300. We extend that out after 4 years, and that's the third year, you're going to have to pay an amount of £150, and then at the 5th year you're going to have to pay an amount of £500. Okay, so suppose the interest is being charged at a nominal rate of 5% per annum, payable every 6 months. So the way we denote that is like this, equals 5% per annum, which means the effective rate, and I write like this, i.e. the effective rate is going to be this 5% divided by 2, which is 2.5%. Okay, so now we can use this effective rate for discounting or compounding cash flows however we like. So let's look at part A. So what single payment in 6 months' time will pay off all 3 loans? So if you wanted to pay off all 3 loans today, you'd have to discount each of these back, the time periods that they're due. So we're looking to discount it back at 6 months or half a year's time, which means this is going to go back, this £300 will go back 1.5 years, or in fact 3 time periods. This one over here, this 150, will go back, what would be 3.5 years, but in fact it's going to be 7, and this one is going to be 9. Okay, so all we have to do is write down the cash flow amount discounted by 1 plus the interest rate of 2.5% to the power of, and what did I say it was? I said it was 3 time periods. The next one, 150, divided by 1 plus the interest rate, and that's going to be to the power of 7 time periods, and this one, 500 divided by 1.005 to the power of 9 time periods. So that's 10 time periods to bring it back to today, less a half a year, which is only 9 time periods. And then we just find out the answer. So I'm going to use Excel in this case to find this one out. So the first one was 300 divided by 1.025 to the power of 3. The next one was 150 divided by 1.025 to the power of 7. And the next one was 500 divided by 1.025 to the power of 9. And we'll sum up all of these, and it should be some number less than 950, which is the sum of all the payments, £805.13. Okay, that looks feasible. £805.13. Alright, so if we were to pay it all in 6 months' time, that's the amount that we would need to have at that time. So let's look at part B. At what time could a repayment of £950 clear all 3 debts to the nearest month? So if we were to, let's take this £950 and we're going to discount it, but we don't know what time period we're going to be using. Okay, so we've got some amount here. We want to know what time period it could be to clear all the debts. So it's got to be great enough to clear all of these, to get rid of 300, 150 and 500 in some amount of time. So the thing to do is we're going to discount each of these and bring it to today's value, to the present value of today. And then we'll be able to know how far we can discount 950 in order to cover all of that. So it's going to be very similar to to what we did in part A, to the first bit, but instead of doing it 3 periods, we're actually going to bring it all the way back to here, to the start, and that's actually going to be 4 time periods, 4 half years. Okay, the 150, the second loan, is going to be brought back 8 time periods. So that's 4 years times 2 half years. And the last one is going to be discounted 10 time periods, 1.025 to the power of 10. Okay, so let's find out what this amount here is equal to. I'm going to use Excel again, and I'm just going to clear that one up, make that a 4, clear it up here, make it an 8, and make this one a 10, and so that should give this number over here, £785 785.5, so that's fine. So 785.5, and now we'll just find the value for t over here by solving for t. So we have 950 over 1.025 to the power of t being greater than 785.5. So now I'm going to multiply both sides by 1.025 to the power of t, and divide both sides by 785.50. So I'm actually going to get 950 and 785.5 is greater than 1.025 to the power of t. Then I'm going to log both sides, the natural logarithm. So I'm going to get ln 950 over 785.5, and that's going to be to the power of ln 1.025, and it would be to the power of t, but if I plug it, which is a rule that I can do, I can bring the t, multiply this log of 1.025 by the t over here. And then I'm just going to divide both sides by this bit, ln 1.025. And I'm also going to convert it and rewrite it like this, so t is less than, still makes sense, less than ln 950 on 785.5 divided by ln 1.025. Alright, and let's find out what t will be. So it's going to be equal to ln 950 divided by that original number that we used, 785.5, and we've also got ln 1.025, and we'll take the first one divided by the second one, so it is 7.7. Okay, so we get here t is 7.7, is less than 7.7. So what exactly does that mean? Well, that's 7.76 months, so 7.7 half years. So t is actually going to be less than the actual amount of months that we want, because that's what the question asked for, to the nearest month. So to find out the nearest month, because that's 7.7 half years, we actually won't call it a t. We'll just say it's got to be less than 7.7 times 6, which is going to be roughly 42 point something. I'll go back to Excel. Equals that times 6. It's sorry, not 42. Yeah, 46.2. All right, so there's 46.2, and we got to round it, so it's going to be approximately 46 months in order to clear all 3 debts of £950. Okay, that's what time period a repayment of £950 would cover all the 3 loans, 46 months.